Hello friends, welcome back to my channel, and today we are going to discuss about festive lighting. So as you know, this month of October and November in India, this is a month of festivals, and a festival is never complete without the festive lightings. So here we are. Today we are going to discuss about how to make this festive lighting smart through the DIY route. Let's talk about that. So mostly, when we go to the market, purchase the LED strips or LED lights, like the ones you see behind me, these are pixel lights. So basically these pixel lights you go buy from the market. They come with their own controller and their power converter that converts AC to DC current and then goes through this lights to light them up. But every time you have to turn on and turn off every evening and every morning, right, during the festivals, and that doesn't seem smart. That feels like a bit old school. So how to make that smart? So you have in your house a router, the good old router for your home, right? So you have a home network, and what if we think about controlling these lights with that home network, from any of your devices connected to that network? We can do that with the help of WLED. Let's talk about that. So this is the ESP8266 controller that you can see over here, and this is basically a Wi-Fi controller that will provide data input to our WLED lights, and controlled by WLED software, and it is connected to our home router. This is our SMPS unit. Basically this is 80 watt SMPS, and it converts AC power into DC power. Okay, so when purchasing a SMPS, note the voltage and the power outputs. I'll show you how to calculate the power requirement for your WLED lights. On the terminal side, you can see on the left side, the left two ones are the AC power ins that are coming from your switchboards, and all these left 6 number of terminals, that means 3 pairs, these are all DC terminals. So this goes to your LED lights. So this one here, this is another SMPS unit. This is a 40 watt SMPS connected to our Node MCU ESP8266 board that is online currently. So once that is understood, let's understand how we can calculate the power requirement of our LED. Just make sure that you note the exact number of LEDs that you have in your light strip, and let's say you have 10 number of LED lights in your light strip. So do know that each LED light, they are basically 3 number of LED lights, and each LED in those having 20 milliamps of power requirement. So 20 into 3, that means 60 milliampere. 60 milliamperes, so that is the current requirement per LED. Multiply that with the number of LEDs. So 60 into 10, 600 milliamperes. 600 milliamperes, so that means 0.6 ampere. So voltage into ampere, multiply it with voltage. So you have, this is a, if it's a 5 volts, so 5 volt, 5 into 0.6, so that you get wattage. Okay, so now since we know about WLED, and that we have to install it in our ESP8266 Node MCU board, let's just head over to WLED website prepared by Air Cookie. He is the person who made all this possible, so a big thanks to him. And okay, search it in Google, and you can head over to the first link that is available here, WLED page. So from here, what we have to do, we have to download the software that will be creating a server onto our Node MCU board ESP8266, and that will connect to our home Wi-Fi network, and thereby connecting to our mobile devices or our laptops that are connected to our home network. So that is the idea, and that is how we are going to proceed. So as you can see in this home page, this is welcome to my project WLED, fast and feature rich implementation of ESP8266 or ESP32 web server to control NeoPixel LEDs, or also SPI based chipsets like WS2801, maybe all this. So basically the lights that we are going to configure, these are pixel lights WS2811. These lights, if you are having strip lights, LED strips, so those are basically WS2812Bs. Those are addressable LED strips that can be programmed and controlled. So with that, there are several features you can check out on your own in this section. So now we are going to head over to the basics. This is a getting started page where you get an exhaustive details how to uh, connect and wire your WLED installed node MCU board to your SMPS and the LED strips or pixel lights. So here you can see there's a quick start guide. So let us just give you a brief overview how to connect your node MCU board to your LED lights. So you can see in here, this is the main power supply, phase and neutral coming from your AC to your SMPS, that is converting the AC 220 volt to a 5 volt supply, DC supply. So this DC supply then goes one section to your ESP board, ESP8266 board, and the other part goes to your LED strips or the LED lights that you have. Same for the ground coming from SMPS, one part goes directly to your ESP board, another part going to your LED strips. And from your ESP board, you don't need a level shifter here because we are not you are using a full scale ESP8266 board here. So from your ESP8266 board, from the D4 pin, take out the signal, that is the data signal coming from the ESP board, and just directly connect it to your uh, data pin that is in the middle section of your LED strip. So that is how we are going to configure it. You can read this section in detail to get further idea about how to do it. So now coming up to the installation part, there are several ways of installing it. We'll be doing it through the graphical user interface. You can install directly the WLED binary. I personally prefer with a graphical user interface, that is easier for me. So I'll be showing it accordingly here. So first there are three sections: download the bin or binary file, then using that flash it with a flash downloader tool onto your ESP board. For downloading the binary, go to this page. You can get the precompiled binary on this page. So here you get this is in this section you get this is the binary file, ESP32 bootloader v4 bin, or these are the binary files. You download it and then head over to here back again, and then download the flash downloader tool. So flash downloader tool you can download from here. This is the link given. So ESP if download website, so from there you can download this flash downloader tool. So here as you can see we have connected our ESP8266 board with our laptop, and the blue LED is glowing. So in the first time when you are going to connect the brand new PCB with your laptop, the blue LED might not glow in the first time. Don't worry, just flash it with the flash downloader tool that you just downloaded from the WLED website, and this LED will start blinking for a few seconds. If it's not start blinking, there are two pins over here. As you can see, I'll be showing it over here. These are the two pins. You just press, keep it hold, so this resets this PCB, and once it is resetted, flash it again. Once you flash it, then it is good to go. So now since you have downloaded all the required files, we are here in this folder WLED. I have named this folder as WLED, and I have downloaded all these files in here. So this is basically the flash downloader tool that you just downloaded from the WLED if website, and if you unzip it, you get this file, flash downloader tool 3.9.3. You open it, and this is basically the binary file WLED 0.13.3 ESP8266, because the board that is here, that is ESP8266. So you should get the required binary file accordingly. So now you open the flash downloader tool, click on the flash downloader tool, and it will give you a graphical user interface in a few seconds. If it's not coming, don't worry, just close it and reopen it. Should work. Yeah, there we go. And now you can see a chip type is ESP8266, work mode is development. You have a factory mode, but you don't need to go for a factory mode, go for a development mode and hit on OK. So that gives you this graphical user interface. So now just keep in mind that you have to select one. Here you have to give the binary file that is here, and that you can get from here. This is your required binary file. You give it here, so screen, that means you're good to go. And now you set this SPI speed as 80 megahertz and SPI mode QIO, that is fine. Do not change pin, that is okay. Just change the BAUD to 921600, that is good. And now you can go ahead and flash it, but problem is if you try to flash it, you cannot, because the reason is that you don't have a COM port over here. This is showing red. So you must get a COM port, and currently that means you are not getting a COM port. That means your chip or the ESP board is not communicating properly with your PC. So let's just see what is happening over here. We just minimize it and right click onto the Windows button, go to device manager, and in the device manager you can see that in the other devices section you have this CP2102 USB to UART bridge controller that is not working properly. So you can see this is showing an exclamation yellow mark. So we need a proper driver for this. So no big reason to worry, go head over to your Chrome, trusty Chrome, and open CP2102 driver, hit on enter, click on the link Silicon Labs and go to the download section, downloads and install PCB drivers. So this is basically a UART to USB driver that helps to communicate between the PCB and your PC. So CP, that this one you need, CP210 universal Windows driver, and that's it. You downloaded it, fine. I have already downloaded it in here in the same WLED folder, somewhere here, WLED folder here. So I have already downloaded this file, and now what you need to do, you need to just address your device manager to use that driver for this device. So go for update, right click, go for update driver and browse my computer for drivers, and browse, go to my wherever you have saved it. So if it is this PC, go to downloads, then WLED, then I have this folder, and CP210X universal Windows driver, that would be the folder name. Hit on OK, hit on next, and it has installed the driver properly. Close it, screen will refresh, and now you can see it is showing a port number Silicon Labs CP210X USB to UART bridge controller COM3. So now it is showing COM3 port. Now let us just head over to our old friend here, that is our flasher tool, flash downloader. Okay, and now you have it, COM3. Oh, select here COM3 port, there you have it. Check the VAUD as 921600 and SPI speed as 80 megahertz, SPI mode as QIO, and then you can go ahead and hit on start. So it will go ahead and flash your drive. I have already flashed my system, so I'm not going ahead to flash it. Once you have flashed it, your ESP board is ready to go, ready to connect with your light. So now that you have properly installed WLED onto your ESP board, now let us head over to the part how we can connect it to our home network. So currently the WLED software is only installed, but it is not connected to our home network. So if you go to your Wi-Fi setting, you can see you have another network, WLED AP. This network you can see over here. So just connect to it. If it asks for a password, given password is WLED1234 probably. Uh, okay. So now it has been connected to the network, and now let us just head over to our Chrome and open this website 4.3.2.1. Enter. Oh wow, now you have entered into the WLED interface. So this is basically you are inside the WLED server that is currently running on your ESP board that we just freshly installed. So head over to the configuration. You want to connect it to your home Wi-Fi network, not through this WLED access point. So name, connect to existing network name. So I'll give my network name and network password like that. MDNS address something, this is this. Configure access point name. So you can configure the access point name and access point ID. This is the access point ID in case there is no your configured network is not available in the range. It will automatically open its WLED access point for you to connect to it. So once that is done, save and connect. So now it closed it window. Head over to your network, go to your home network, connect to it. Okay, and now you are connected to the WLED through your home network. Now let me open it. You can see since I use this one in my home network, I have this already tested, and this is the local IP address that I have for this one. So if I click it, it should open the WLED user interface that it has opened. But for the first time you will not be having this IP address, right? So what you can do, go to your router's DHCP control panel, and there you can find the client list in which you will find one that is named as WLED. Note the IP address for that, and go back to your browser, open it. So now that you have connected it, you are now ready to configure it. You can click on this pick one so that you can see what is the color currently on your LED lights. And this is the color wheel that you can see over here. This color wheel, you can choose whichever color you want. That color will be reflected on your LED lights. Isn't that great? So you can choose three colors. Color one, taken this pink color. Color two, you can take whichever. Let's say green color I want. Color three, let's say I want something in the blue region, so blue, or you can take this blue. So that is it. And then you can choose, go on to effects, and let's say you want this effect, this one. You can choose this one. There are more than 200 LED configurations that are available, LED effects that are available, and you can use any one of those from your laptop browser. And also one other thing, you can use the same thing from your mobile. There is an app you can check out in the Play Store named as WLED, also in Play Store or App Store, whichever you are using. So from there you can download it, search for new WLED configuration on there, and it will automatically detect WLED interfaces and connect it in your network. So that is pretty easy and interesting part. I thought to share with you since I love this kind of projects personally. Hope you have learned something from this, and um, If you have enjoyed this video, please give it a thumbs up, hit the subscribe button, ring on the bell icon, and I'll see you in the next video.